Hello everyone, and then welcome to another tutorial video. So in this video we'll be just treating the chain rule. Okay, so this is what an application to partial derivatives, but this is under chain rule. Okay, so we are treating chain rule under partial derivatives. Okay, right. So in this video we'll be treating how to find a chain rule for specific expressions, okay, with the use of what the partial derivative. Okay, so when it comes to general differentiation, we have ways of implementing the chain rule, okay, to help differentiate. But with respect to this, we have a mixture of what x and y, okay. So we'll be using what the chain rule to partially differentiate certain expressions. That's with respect to what x and y. Okay, so in case you are new to this channel, I would urge you to subscribe to the channel, turn on your post notifications so that you don't miss out on newly uploaded videos. Like the video, share, and then in case you have any questions, just leave them in the comment section, and then we'll reply to them as soon as possible. Okay, now let's dive right into this tutorial video. So we have what the chain rule for or the chain rule under partial derivatives. Okay, so now let's see how we do that. So we have z is a function of x and y. That's why initially I stated that the function will be a mixture of x and y, and then you'll be given specific functions for x and then specific function for y, because you'll be partially differentiating. So we'll take z as a reference point, and then you'll be given specific expressions for x and y, right? So we have what the change in z per the change in t, because that's what we'll be using. We'll be using the change in t because these x and y expressions will have t as their what variables, okay, where we'll be taking into consideration to differentiate, that's partially differentiate. Okay, so we have what this expression could be just simplified as this. Okay, so we have f of x changing x over changing t, just as I initially stated over here, plus what f of y changing y over changing t. So in case you know how to use the chain rule with respect to when it comes to differentiation, this will be familiar to you. Okay, so you try to keep one expression, differentiate the other, and then after that you add the already differentiated expression to the other expression where you are trying to keep one and then differentiate the other. So this is what that implies. Okay, so from here you initially state that the change in t always approaches 0, so is that much insignificant. Okay, if something is really approaching 0, that means it's very, very small. Okay, so we have what now. I want you to keep something in mind. Keep this expression in mind, the one being covered with what the red box, or the one in the red box, and then this expression in mind, because this will help you solve every problem, okay, when you come across every problem. So in case you don't understand this, just keep this in mind. Okay, just keep this expression in mind, but you can also try keeping this expression in mind because it's the same principle. Okay, but this is much simplified. So from here you have the f of x being, you take the differential of x with respect to t, and then you add that to what the differential of y with respect to t, that's for f of y. It's the same chain rule. Okay, it's the same chain rule, but for this principle we are using it with respect to what partial derivatives. Okay, this is quite simple. Once we solve an example, you will notice that it's very, very simple. So this is what I want you to know. Dx means that we are differentiating z with respect to x. Okay, zx means that's why initially I said that just ignore this portion and then keep this expression in mind. Okay, zx means that we are differentiating z with respect to x, and then after that you multiply that by what x prime of t. X prime of t means that you are just differentiating x with respect to t, and then after that you add it to what zy. So zy means that you are differentiating z with respect to y, and then you multiply that by what y prime of t. That means that you are differentiating y with respect to t. So the zy zx means what partial derivative. So the zx will mean that you are partially differentiating z with respect to t, because you might have a y attached to the expression. Okay, same applies to zy. So let's take an example from here so that we see how it's done. So let's look at this question. So we have what if z equals y squared x. So as I initially stated, it's what partial differentiation. So you have combination of x and y, and then you have what x being equal to t exponent 4, and then y being equal to what? T exponent 3. And then we are told to find what? dz dt, just like here. To find dz dt, we'll just use this expression, okay? So we have this prime of t, okay? And then you add that what? Z of y, and then what? Y prime of t. So this is what it simply means, okay? So this, for zx and zy, we are just partially differentiating z respect to x and t respectively, okay? And then for s prime of t and y prime of t, you are just differentiating s respect to t. So let's see how that is done. Okay, so we know that z is equal to what? Y squared x. So let's take what? The partial derivative of what? Z respect to x, okay? So when you differentiate z respect to x with this expression, so in case you've watched our previous video on partial derivative, this will be much simpler for you. So you can notice that we have what? Y squared over here, because when you differentiate x, you end up at what? 1, okay? And then when you partially differentiate z respect to y with this same expression, you end up at what? 2yx, okay? Now let's proceed. So from here you also have what? X to be equal to what? T exponent 4, okay? T exponent 4. So when we take what? The x, okay? The t, that is the same as what? X prime, okay? That is the same as the s prime over here, s prime of t. So let me just put the t in the brackets, okay? So when you do that, from here you have what? 4 t exponent what? 3, okay? So the same thing applies to the y. We have what? Y to what? 2t exponent 3, okay? So when you take what? The y, the t, you end up with what? The same thing. It's the same thing as y prime of what? T, okay? So when you differentiate this, okay, so you end up with what? 6t squared, okay? You see how simple this is? It's just simple. All you have to do is just go through the procedure, okay? Just follow the procedure, and then you use the formula, okay? Just like implicit differentiation. So in our next video, we'll be talking about what? Implicit differentiation. So now you're what? The z, okay? The t, which is what? Zx multiplying what? Z prime of t plus what? Zy multiplying y prime of t, okay, is the same as what we've solved over here. So let's look for what? Zx. So zx is what? Y squared, and then you multiply that by what? Z prime of t. So z prime of t is what? Okay, that's over here. That's what? 4t exponent 3 plus what? Zy. So zy is here. That's what? 2yx, and then we have what? Y prime of t, which is what? 6t squared. Okay, so from here you can notice that we do not want to have a mixture of y and t and x, okay? So we want everything to be uniform, because the general expression is stating that we need what? The z on what? The t, okay? We want z respect to t, not z respect to y, x, and t. So all you have to do right now is just substitute your y's with what? Your t's, and then your x's with your t's. But initially, we got to know that our x, okay, our x is equal to what? T exponent 4, and then our y, which is here, is what? 2t exponent 3. So that's all we have to do. We just have to substitute the x and y, which have t's in them, into the main expression. So for y, we know that y is what? 2t exponent 3. So I'll write that in red so that you get to understand. So 2t exponent 3, and then y is what? Squared. So let's put the entire of y to bracket, and then let's square it. And then we have what? 4t what? Cube. So we have what? 4t cube, and then plus what? 2y. So let's do that again. So we know that y is what? 2t exponent 3, okay? And then you know that x is also what? T exponent 4, okay? T exponent 4, and then you just multiply that by what? 6t squared. You see how simple this is, okay? This is very, very simple. Now, all you have to do is just do your simple expansion. You just multiply things throughout and all that. So, let's see. When you multiply this, okay, so when you multiply this, we have what? Okay, so let's expand this, okay? So, when you expand this, you get what? 4t, okay? This will multiply that, so you have what? 6, okay? And then you multiply that by what? 4t cube plus what? So let's bring the 2 out and just concentrate on what's in the brackets. Okay, so we have what? 2t what? That's 7, okay? 7 because we are multiplying. Okay, indices. So we are multiplying, and then indices means, you know what I mean? It's indices. So since we are multiplying, the exponents will just add up, okay? And then we have what? 6t squared. So let's just do simple expansion. So we have what? 16t, that's 9 over here, right? And then we have 2. So this will give us what? 4, 6. Okay, so we have what? 24. And then we have t, they are multiplying, so they will add up. That's 9. Okay, and then once you take what? You just sum these two up. You end up with what? This is 16, this is 24. So that's what? 40, and then t exponent what? So since we are just adding, you just keep the what? The t exponent 9. Okay, so you see how simple this is. This is very, very simple. So once you know this, you are just good to go. Okay, you are just good to go. You won't have any problems with what? Solving these questions. So let's move on to what? Chain rule for what? Partial derivative. So this was just the general concept of chain rule. Very, very simple. Now let's look at what? Chain rule for what? Partial derivatives. So now this is what? The chain rule for partial derivatives. Okay, so the same principle is just the same principle. Okay, there's no need to be frightened. Okay, it's just the same principle. So we have a chain rule for partial derivatives. So the same principle. So we have z. I'm having a function of x and y. That's a mixture. That's why we call it what? Partial derivatives. And then you'll be given a specific function for x. So for here, you could notice that for our initial question, we were given what? An expression for x, even though we had z with what? A mixture of x and y. And then you'll be given a function for x with respect only t, okay? And then y is also with respect only t. But for this, the method we are about to treat, after being given a function for z, okay, you'll be given a function for x with respect to also 2 variables, okay, not only one, 2 variables, and then y will also be given with respect to 2 variables instead of 1 over here. So I just wanted to clarify that. So let's proceed. So from here, that's why we have what? The function of x given in what? U and v, and then the function of y also given in what? U and v. And then all you have to do is just use the same principle, because the same principle runs through it. So you just differentiate z respect to u, and then you come up with this expression, okay? And then you take the partial derivatives, okay? And then you come up with this expression. So again, I'll give you a specific expression to keep in mind as always. So keep this expression in mind, because that will be a reference point, because from every point of the calculation we'll be referencing from that expression. So let's look at how we find the solution to this question. Okay, so we've been given z to what? E, x, and y, and then we are given what? X to what? 2 functions, okay? Function of u and what? V, and then we are given y to what? Also a function of what? U and v, okay? This is just equal to science, nothing much. Now, this is how you go by this. So for this, we are told to find what? Zu, okay? Z of u. And then z of u is just simple. That's the same thing over here. So z of u will just run through, okay? So from here we have what? Z of x, and then you multiply that by what? X of u, and then you add that by what? Z of y, and then you multiply that by what? Y of u. So it's the same principle over here, okay? The same principle over here as we initially used, okay? This principle, I'm referring to this principle, okay? Right, so from here we were told to find out the z dt, so we just use what? X and what? Y, and then we have the t respectives, okay? So after finding what? Zu, you also find the v. which will be the same as what? ZV being equal to what? ZX, okay, multiplied by ZV, and then plus what? ZY multiplied by what? YV, okay? That's how the principle works. It's very, very simple and straightforward. Once you know this, you are just good to go. Okay, right? So let's proceed. So this is how you go by what the solution. First, you just allocate the expression for x and y. That's for the partial derivative. That's why we have what? Zx, zy, and then you are taking that with respect to only u. Okay, so we have xu and then yu. Even though we have a mixture of u and v in what the x expression and y expression, we are just partially differentiating with respect to only u. That's for this question. Okay, so let's see how we go by that. So the same principle applies. Okay, we first find zx. So this is zx, so we have what? The z to what? This is the z. Okay, so we are differentiate or partially differentiating with respect to only x. So when you do that for this expression, you have what? Y, okay, e exponent x y. Okay, that's for zx. Let's find zu. Okay, so for zu, sorry, for zy, okay, for zy we have what? X, okay, and then you have exponent xy. So this is what? For x, zx, and then what? Zy. Now let's find what? Xu, okay, let's find xu. So now we know that this is su, okay, this is our su, which is what? 2u f v. This is v, okay, keep that in mind. So we are partially differentiating with respect to only what? U. So when you partially differentiate with respect to u from here, you end up with what? 2, okay, you end up with 2. This is what? Fv. Keep that in mind. It's not 2uv. 2uv is different from 2ufv. The fv is like a function on its own, okay? So in case it was maybe 2uv, our answer would have been, for the partial derivative, we would have gotten something like 2v, okay? But this is what? 2ufv. It's like a function on its own. So when you do the partial derivative for here, you end up with only 2, okay? Right. Now let's look at what? Yu, okay? That's where we are just partially differentiating with respect to only u. So for yu from here, okay, so again, so let me just do this right now so that I clarify things here. So y, which is equal to u what? V, is the same as what? U multiplying 1 over v, okay? Keep this in mind. Keep this in mind. So when you take the partial derivative, you end up with what? 1 over v, because when you differentiate or partially differentiate u multiplying 1 over v or uv, you end up with what? 1 over v, because the u will convert to 1, okay? The u will just convert to 1. Now let's just use the expression, okay? Let's just use the expression. So we have what? Zu. So now we are just substituting, okay? We are just substituting. So you know zx to what? This expression. So we have what? Y e xy, then multiply by what? Xu, which is what? This expression, okay, which is 2. And then we add that to what? This point means that we are multiplying, okay? Keep that in mind. So and then we have what? Zy, which is what? This expression x e exponent what? Xy, and then you have what? Yu, which is what? 1 over v. So from here you could notice that we have a mixture of what? Y, x, y, and then we have what? V, okay? We have y, x, and then v, okay? So this is how the expression will look like. So after this, you can just do your simple expansion, okay? So you could get something like 2y e exponent xy over here plus what? We have maybe it could be 1 over v, and then we have something like x e exponent xy. You could just leave it like this, okay? You could just leave it like this. You could notice that this different from what we did over here, okay? So from here we weren't given 2 variables for what, or 2 expressions for the x and y, okay? Just like here we were given only y to be what? It will be called only 2t, not something like y to be equal to 2t q, maybe v or q or whatever. The variables corresponding to y were only 1. Same applied towards x. That's why in the end we try to substitute the y's with their respective expressions containing t, so that it will be what? Uniform. Okay, so the same thing applies over here, but for here you could just leave your final answer in this format. Okay, there's no need for you to proceed to do anything else. So this could be your final answer. Now let's look at this portion. Okay, so the second portion was to find what? ZV. So we already know what zx and zy are. Okay, these are our zx and zy. These are zx. Okay, these are zx. Okay, and these are what? Zy. Now all you have to do is just find xv. Okay, so for xv, so we know that this x. So now all you have to do is just partially differentiate x with respect to only v. So when you do that for here, note that I initially stated that this a function on its own. Okay, f of v is a function on its own. So when you differentiate only v, you end up with what? 1 s respect to only v. Now let's find what? Y respect to only v. Okay, so from here you can notice that this was u on what? V. So let's first write that, so that I will try expand it so that you get to understand the concept. So we know that y is equal to what? U on v, which is the same as what? U v prime. Okay, so when you differentiate this, that's y p, you end up with what? Minus uv minus 2. Okay, minus uv minus 2. Keep that in mind. You have a negative sign over here. Okay, have a negative sign over there. So in simplicity, you can just expand this, and then you end up with what? Y, because this is 1, you just multiply that one out, and then you have what? Xy plus what? Since you have negative sign here, you could just remove this positive sign, and then you end up with what? Minus maybe u on v squared coming first, and then you have what? X e exponent what? Xy. Okay, see how simple this is? Very, very simple. And then I hope you enjoyed this video. In case you did, kindly subscribe to the channel, turn on your post notifications so that you don't miss out on newly uploaded videos. Like the video, share, and then I will see you in the next video. Have a lovely day. Bye bye.